Hey, does it work?
Yes, perfect. Audio works. We're in the practice session at around 50, and my keyboard lost connection, so that's great.
Let me check mine.
Why is my
9258? I'll put the charger in.
okay. Always a good idea. Yeah, in many ways, I just want to do more wired things. Like, just wireless is awesome, but man,
Yeah, I kind of agree.
it can be annoying sometimes. All right, I will start it in just a few seconds. Perfect. Documentation's in the PR. All right. There we go. We got people rolling in. Hello, everyone. Great to have you here. And then I will. Where's everyone joining us from? Got people from Netherlands and France. Nice. A lot of Europe. Okay.
I see former colleagues here, or one at least. Hi, Evie. Or I'm guessing it's her. It might be someone else with the same name.
There you go. Very much a possibility. Can you see my screen? Yeah.
Yep.
Cool. Is it recording? I think it is. Let me see if it's, yeah, we're good on recording. Cool. Welcome, everyone. We'll wait for a few more minutes, let everyone trickle in, and then we will get started. Make sure my notifications are off. Yes. Awesome. We got 25 people so far. Where's everyone joining us from? You can kind of add your submission in the chat. We'll get started in about 2 minutes. All right, we're up to 30 people. Give it another minute and then we will start the program. Okay, people from Maryland, California, Milan, Italy. I think your friend is here, Villa.
Yeah.
Sao Paulo, Chicago, IND. I have to assume that's India, but that could be Indianapolis or Indiana. Awesome. All right, we're 4 after the hour, so let's start this live demo. Thanks everyone for coming. Today we'll be kind of walking through how to build a database connector for Superset from scratch. It'll be kind of a nice, fun live demo with a lot of live coding. So it'll be kind of a nice show, and we'll kind of really be walking through a real example. So this will be very practical, not too theoretical. So here's kind of a quick overview. We'll start kind of with the initial background and context, like why is this an interesting thing for Superset, and just more generally, what does it say about open source and BI? Villa will then do kind of the live coding demo, and then we'll end with Q&A. As I pointed out here, please submit questions throughout the entire presentation. There's a Q&A tab at the bottom. Any questions we can answer quickly through text, we'll do that. Otherwise, Villa will answer them live at the end. And I'll pass it off to you, Villa.
All right. Hi, everyone. So my name is Ville Brofelt. I'm a visualization engineer at Preset, and I've been contributing to the Superset project for about 3 years now, and recently became a PMC member for the project. Yeah, so I'm gonna like Srini said, I'm gonna be kind of doing a live coding demo here today. Kind of starting from scratch, adding support for a new database connection to Superset. And I'm gonna be assuming some prerequisites in SQL, Superset, and Python. So it's good to know some of these areas, and but this is fairly simple stuff at the end of the day. So if you're not kind of a pro on one of these things, I think you should be able to manage. Yeah. So if you can take the next slide.
Sure.
So the Superset was originally developed for Apache Druid around 5 to 6 years ago, and the reason why Superset was originally developed was the fact that other BI tools didn't really support Druid back then. So that was kind of the whole kind of reason for the project starting. However, over time, there kind of arose the need to start connecting to other data sources. And when Max was developing this at Airbnb, they were rolling out a big Presto cluster. So they wanted to access the Presto cluster from Superset. And the simplest way of adding support for that was adding a support for the PyHive SQL Alchemy connector, which then gives you access to Presto fairly easily. So that's how support for SQL Alchemy was originally added to Superset. And over time, this has kind of been growing all the time, and it's actually kind of reached the point where the original Druid connector is kind of being deprecated, and it's only loosely supported anymore. So so practically all database connections are actually done with SQL Alchemy nowadays, and even the Druid connection is nowadays mostly being done using SQL Alchemy. So the PyDruid library actually offers a fully native SQL Alchemy connector as well that you can use to access the same Druid clusters, but by using SQL rather than JSON or REST. And there's essentially two levels of integration in Superset. So the first kind of bare minimum requirement of connecting to a database is having at least a DB API 2.0 and SQL Alchemy driver. So without those, you won't really be able to connect to your database without making a native connector to Superset. And I haven't really seen any other native connectors out there other than the original Druid implementation. So I wouldn't recommend doing the work of integrating natively to any databases. So usually if you have a SQL Alchemy connector, you can fairly easily just by installing the driver, adding the correct connection string to Superset, that will usually kind of get you started fairly quickly. So you should be able to write SQL queries, query tables, and do some kind of basic visualization, something like pie charts, histograms. So anything that kind of relies on standard strings or numerics, kind of making aggregates on numerical values, that kind of stuff usually works fairly well. However, once you actually start using this, it tends to turn out that things don't work very well. And one of the reasons is the majority of SQL Alchemy connectors are usually kind of, well, they're more or less kind of hobby projects for the original developers. So they're not extremely reliable, and then they often have small quirks. So where the SQL Alchemy spec requires you to be returning, say for instance, a list of values, some connectors return tuples, some return sets, some return none values. So you have to kind of learn to deal with this stuff, and to be able to facilitate that kind of stuff, Superset offers this database integration layer called a DB Engine Spec. And a DB Engine Spec is essentially a set of kind of overrides or hacks that help you kind of introduce functionality that either the connector itself is lacking, or then just kind of other valuable things that Superset relies heavily on, but isn't in the SQL Alchemy or DB API spec. So for instance, time grains, kind of date truncation functions, having a mapping between, how do you truncate a date time or a timestamp to weekly or daily or monthly observations. So that's one thing. Then kind of date parsing or formatting functions, functions for changing between epoch format to date and vice versa. So usually these when people add a new database connector to Superset, they tend to start out with just something like 20 or 30 lines of code, and then over time they grow quite a bit, and then over time they become fairly massive. So that's kind of some of the basics of how the database integration layer works in Superset. And I think you can jump into the next slide. Yep. So what we're going to be doing today is we're going to be adding support for CrateDB. And this is a database I don't really know all that much about. You can read the description here. It sounds like a very interesting database project. And Srini was able to kind of find a SQL Alchemy connector for this. So we decided, hey, let's see if we can integrate this with Superset. And so I'm going to be walking you guys through what I essentially had to go through to make this database work well with Superset. So let the demo begin. So my demo is mostly based on actually two blog posts from the Crate community. So one, they've actually done a blog post explaining how to connect to Am I, by the way, sharing the screen?
Yeah, we can see it.
All right. Yeah, so they have a blog post that actually outlines how to use CrateDB with Apache Superset and how to get this all working. I kind of followed this tutorial. This is actually a great tutorial, and they have another one as well for populating data. So I've got the links here in the presentation. Check them out later on. I won't be kind of reciting all of this stuff live here. But it essentially kind of starts out with, of course, you have to get the database working first. So they have this bash command where you just type one line of code and then it fires up the database. And I've already done that once, but I'm gonna do it here. So essentially just firing up the database here. So this is, right now, this is just kind of starting up, I think, some kind of a Docker container. And it should usually open up a new browser when it's started. Let's see. So here we go. So now we have the cluster up and running. And here in the tutorial, there's actually a great example of how to get kind of live position data for the ISS space station. So I modified the script that they provided just a bit. And now that we have this this database running, I'm gonna kick off this script. What this script does is it essentially just it hits one of, I think it's one of NASA's REST APIs, which is providing kind of real-time kind of geolocation data for the ISS. So every 5 seconds or every 10 seconds, this just retrieves the newest values and then it inserts them into the database. So I now have 3 values here at least, and if I go into my admin console, I can see that I have the table here, and then if I then want to query the data, it's kind of showing up here in real time. So this is the data that we want to essentially be exploring in Superset. And now the question is, can we actually get this to work or not? So when I started doing this, I thought this might just be a 5-minute exercise because these guys already did this, but turns out it wasn't quite that simple. So first of all, they in the instructions they just say pip install crate and then it's going to work. And I'll just show you what happens when I do that. So what I'm doing here is I'm running a virtual environment, which my IDE is then also using for running Superset. So now I've installed CrateDB, and then I go into Superset. And now that I try to test the connection here, it's going to say connection failed. And I started kind of looking through why this happened. So I actually went to look at their GitHub repository for the SQLAlchemy connector. And I took a look at their setup.py file just to see if there are any kind of extra requirements here. And it turns out, yes, you actually have to install this with the extra dependency of SQLAlchemy. So this essentially then pulls in the GeoJSON library that seems to be a requirement. So what I then do, instead of just doing pip install crate, I had to then do pip install crate with crate SQLAlchemy. So then this pulls into the GeoJSON library that's a requirement as well. And then I go to my IDE and restart So this takes a while. All right, so now it says connection looks good. So then I can save this, and now that I have a database, now I can actually start adding so-called data sets to Superset. So in Superset, a database is actually a kind of a database connection, and a data set tends to be something like either a physical table in your database or a view. So I'll go and now try to add this ISS table that I just created and that I'm kind of continuously populating. So I go to the dataset page, and then I put plus dataset over here. Then I pick my new crate, and this was in the doc schema, and then I pick the ISS table. And so far so good. So now we have the table added here. It seems to be working fine. So now the next step is to kind of start making sure that things are actually working. So so far, this looks to be fairly okay. So we have it's showing up. It's got the default count metric available, and then it's exposed these 3 columns that we had in our schema or the metadata. So looks fine. All right. So if I then go when I click this now, it's going to fire off a table chart. So now I can take a look. I'll make an aggregate here. So first of all, I'll disable my filters. So I want to get all the data that I have available here. And then I'll just make a, let's see now. Yeah, so I'll include time here. Now, what now happens, and this is where things started getting worse for me. So even though I know from my my console that this is supposed to be real-time data, this is February 2021, but for some reason this is showing up as 1970, the 1st of January. And this, anyone who's been working with this kind of data a lot should kind of see what's happening here. So this is this seems to be interpreting some numerical data as an epoch, and it seems to be assuming millisecond data when it's actually getting second or minute data. So this is a fairly typical problem. And if I just so how do I then go about debugging this? Well, my next step would be going to the SQL editor, because Superset, and this is actually how SQL Alchemy usually works. So SQL Alchemy offers one function for getting column metadata for any table in the schema. So that's one way of getting metadata. Then there's another one if you're actually firing off a SQL query. So then when you're firing off the query, you get a cursor description with it, which tells you, okay, you queried for these fields. Here are the data types for these fields. So if I go into the SQL Lab editor, I'm now not going to be using the get table columns SQL Alchemy endpoint. I'm actually going to be using the execute API and then reading the cursor description. So if I now look at, I've already done this once, I'll do this again. So I just pick the crate database, I pick the correct schema, and then I pick the table. So now it's again showing me that this is a timestamp, and then I have the longitude and latitude. However, it turns out that it's actually returning numerical data here. And so my hunch here is that it's not returning these native timestamp objects, but it's actually returning some kind of numerical data. So I can then kind of check to see if this is correct. So I create a virtual table, and this in Superset you can create these virtual tables which are actually they're wrapping a SQL query within within a subquery. So these are kind of on-the-fly views in a sense. So now when I'm here, I can see that, yeah, timestamp data is showing up as very numerical stuff here. And when I look at the column metadata, it's no longer showing up as timestamp. It's actually showing up as just integer data. So what I then do in Superset, you can change the datetime format. So you can actually be reading in both numerical and string data as long as you provide some conversion mechanism with which you then change that to kind of something that you pass to a parsing function. So there's this built-in functionality called epoch milliseconds. So when I put that in as a datetime format, it should be able to kind of parse on the fly all of these values. And then I flag this as being a temporal column. And then I just save. And so now if I go and try to make a line chart, yeah, now it's going to say not implemented error. And why is that? Well, now we come into why we need a DB engine spec. So the problem is I've asked it to parse using the millisecond epoch function, but I haven't provided one yet. And SQL Alchemy doesn't provide this. So now what I have to do is I have to go open up my trusty IDE, and then I just create a new DB engine spec. So what this DB engine spec actually is it's essentially just kind of giving these extra instructions for what to apply on top of whatever is the base functionality. So I'm going to add a file here called crate, and it's going to be a Python file. And just add it like that, and then I'm going to add the bare minimums here. So of course I've done this ahead of time, so I'm not going to be writing these out myself right now, but I'll quickly walk you guys through what's happening here. So of course, because we're an Apache project, we have to have this header license here. If we don't have this, then it's not going to pass a continuous integration. Then after that, the engine name has to be whatever the dialect name is. So this is always found in a SQL Alchemy dialect. So if I want to be using this spec for CrateDB, I have to put in the engine name crate. And then I've added these two main functions here. So these are this tells Superset how to convert second epochs into timestamps. So it essentially has to multiply by 1,000. And then because the native format was already in millisecond epochs, I just returned the column. So I don't need to have any kind of a kind of date parsing function for this. I just pass the column itself. And then also a date conversion function for converting Python native date times into kind of string representation in, for instance, a where clause. Most of these you don't have to write yourself. So if you're kind of faced with this dilemma, you can look at the umpteen connectors that are already here, and usually there's some other database that's doing the same thing. So when I was writing this one, it actually turned out that this CrateDB acts fairly similarly to how PinoDB does, or Apache Pino. So there were certain similarities, and thanks to one person who had implemented the Pino connector before, I was able to leverage some of that code that he'd written. And then lastly, so we have this function called alter column, and this is essentially when I was adding the table originally, it it got the type timestamp for this temporal column. And in fact, it's not really a timestamp. It's actually an integer field. So what I'm actually doing here is I'm overriding whatever type comes back from the SQLAlchemy function. So when SQLAlchemy tells me that this column is of type timestamp, I actually tell Superset, no, this is actually an integer field, and we'll be treating this as a datetime column or kind of a temporal column, and the format of this column is in epoch milliseconds. So when I've done this, I should now, once the backend restarts, I should be able to leverage this stuff when I'm trying to draw this line chart. All right, so now we have something here that's showing up, and we can see here that now the timestamp is also rendering correctly. Then there's something that's missing here. So now it's identifying the timestamp correctly, but we don't have any time grains. And if I had one of the other databases here, it would be offering me 1 second, 1 minute, 5 minute, 10 minute, 15 minute time grains. But because we haven't defined one of these time grains in our connector yet, I have to give Superset these kind of mappings from ISO kind of time formats to the actual database function that does this date truncation. So of course I've done that already. So let me just copy that over. So I'll go into my IDE, and then here there's kind of a standard mapping where you give the ISO code here as the key, and then you give whatever the function is that truncates your temporal column. So these I was able to find on the CrateDB documentation. So they have actually a very good documentation of what the syntax is. So I was able to get these in just a few minutes. So I put these in here, and now that I save this, it auto reloads. And now that I refresh Superset, I'm going to see that I have all of these time grains available that I just added. So now if I would be grouping by minute, I can see that I'm getting something between 5 and 6 observations per minute, which would be then, it appears I'm ingesting every 10 seconds. All right, so, but now, of course, this is a fairly boring example because I'm just doing kind of counts, and this is geospatial data. So I could, of course, take a look at what the longitudes and latitudes look like. So let's do that now. So now I'm essentially calculating the maximum max longitude and max latitude on a minute basis. So now it appears that one of these is going down and one of these is going up. Okay, this isn't very interesting either, but of course we can put this in another context. And fortunately, Superset has a bunch of geospatial visualization options. So I can then choose the scatter plot, and then I put in longitude or lon for longitude and lat for latitude. And then I plot this. And now it appears, I think what it is we have the ISS somewhere above Africa or Eastern Africa. No, Western Africa, sorry. So this was pretty much it. So to kind of reiterate what we just did. So we started out without any database connector or any DB Engine spec, just connected to the database. We're able to use SQL Lab. We were able to add tables as data sets. We were able to visualize those. That there were some kind of time or temporal conversion errors, but those were fairly simple to fix. And actually, you don't really need to know all of this that well, because you can just look at the existing specs that we have implemented here, and then if you find something that seems similar, then you can just kind of reuse that code and then add it here as a new one. So at the end of the day, I'm not sure how long it took for me to do this, but and I've done this a few times before, but I think this is actually a really good way of kind of onboarding yourself to becoming a Superset committer. So this is kind of fairly low-hanging fruit, and the reason I say this is kind of low-hanging fruit is because it's fairly easy to do, and then once you add support for a database, everyone in the world can be using this. So you're essentially kind of opening up Superset and opening up whatever database of your choice you're adding support for, and once that goes in, everyone else can be using it. So I personally find that very motivating, and it's been a great way to kind of get more involved with the project. So that's, I think, everything that I was gonna be showing here. So I think we can open it up for discussion here.
Yeah, thanks, Villa. If anyone has questions, please use. How about now? Better?
Yeah.
Can you hear me now?
Yeah, it works.
Yes. Okay, perfect. Yes, if you have questions, please use the Q&A button at the bottom. We'll stick around for a few minutes and answer questions as they come in. But yeah, thanks everyone for coming. But yeah, we'll be around. Happy to answer any questions about Superset, new types of databases we should be integrating, the process for contributing, things like that.
Yeah, and actually one thing that I could mention here, so what we've been building as preset here lately is we've deployed this this managed Superset, essentially, where you can just very easily just kind of spin up a Superset workspace, and you have all of these database connectors kind of pre-configured. So and I guess, I mean, we actually opened up the pull request today here with Srini. So this is probably going to be hitting master branch of Superset either today or tomorrow, and then once that happens, I think we'll have this on preset cloud probably in a few weeks' time.
Yeah, definitely. This is the PR. Just a few files were touched, especially if you know the database well. It's not too bad to add, and we've even added some really basic documentation for CrateDB, so people can use CrateDB with Superset. Awesome. Any questions? We'll give it 5 minutes. Oh, we got one. Here we go. Mark asks, can you talk about different SQL dialects? We're unable to use a SQL editor because Teradata does not support a limit by n values. We have to use select top with n values.
Yeah, I remember, and this is a problem, I think, with SQL Server and a few other ones. This was actually a project that I had where I wanted to add proper support for this top syntax. One of the reasons why, well, I ran out of time that time, and then it just got buried under other stuff. But one thing that we try to, because we have limited amount of time for working on this stuff, and one of the distinctions we've tried to make is we try to support NC SQL as well as possible. And the problem here is I think the top syntax isn't ANSI SQL. It's actually kind of, it's something that some proprietary vendors came up with. If top gets added to ANSI SQL, I think we'll be adding support for it. But in the meanwhile, we try to push vendors to rather implement ANSI standard syntax into their dialects rather than adding support for kind of niche features. Because the problem is the more connectors we add, the more kind of maintenance burden we're going to have, and the more we have to maintain non-ANSI syntax, the less time we're going to have implementing cool features. So that's kind of, we try to support databases as well as possible, but that's where we tend to have to draw the line.
Makes sense. Let's give it another 2 more minutes, and then we'll end early if needed. But we'd love to see other questions. Anything at all. No question is too simple.
And by the way, Mark, if you're open to helping add support for this, we'd be definitely open to that. And if you need help, I can definitely help you along the way. So it's more a problem. When I was working on this, the major problem is the limit is placed on a different place than the top syntax. So you have to kind of inject the top expression in a kind of a non-standard place, and it becomes extremely difficult when you have these common table expressions, for instance, or kind of deeply nested queries. The limit tends to be fairly simple to put at the end, but getting the top at the top is slightly more difficult.
Makes sense. It's not a question, but a comment. Igor has a question about Superset with Redshift. They've deployed Superset with Redshift together, and right now it looks like their end users can access all of the tables in Redshift. So they want to know what the recommended way is to override or basically customize the setup so that people can only see the Redshift tables that they are supposed to see access to in Redshift. Yeah, so I'm guessing there's some type of permissions layer.
Yeah, I think there's probably some user impersonation feature that Redshift might be offering. I'm not too familiar with it, but I think most modern databases nowadays offer user impersonation. That tends to be a good way of kind of moving this kind of security layer closer to the database. So you can then, you can request, show me all my tables, and then it's going to show, okay, it's this guy who's trying to get the tables. Then we're just going to show him the tables he actually has read access to. But I'd just check the documentation for Redshift.
Dhanashekhar asks, is there a possibility to connect NoSQL databases? This is a common question.
Yeah, and again, actually, this comes back to my original answer with Teradata. So we've been kind of thinking about adding these native connectors for there would be, I think the MongoDB connector would be a perfect example. The problem is then we have to maintain that, and then Superset starts branching off into becoming more or less kind of a database rather than a visualization platform. So, and looking at what kind of products there are out there, there are actually very good federation databases like Presto and Dremio and Apache Drill that actually do this very well. So, I would recommend actually using Trino or Presto, and then connecting to whichever NoSQL database you want to be connecting to, because odds are Presto should have a connector for that.
Mark again asks, could you tell us how to tell what database is being accessed so we can check for Teradata? I think, Mark, you may need to clarify your question. Basically, every database needs to be added manually to Superset. And so, when you're adding it, you obviously have to, the connection string you put in is going to be the way you specify that. But yeah, we need some clarification and follow up.
Yeah, I think if I kind of understood it the same way as Srini. So this again comes down to how different databases access or kind of expose their tables. But I'm usually the way a SQL Alchemy connection string works is you give it, of course, the host name, and then you give it the database name, and one host might have multiple databases, but those are usually kind of abstracted into one database at a time. So if you have a database instance with 10 databases, you would then have to have 10 databases in Superset. And then usually the MySQLs and Postgreses and those, they all have kind of schemas on top of the database. So, and that's then supported natively by Superset.
Awesome. Well, it looks like that's all the questions we have for now. Thanks everyone for coming. This was awesome. Thanks, Philip, for doing such a great live demo. And we'd love to see more people contributing to Superset in general. And if you're not in our Slack community, I strongly encourage you to join. You can go to the Superset website, superset.apache.org, and hit the community tab. There's a contributing channel on Slack, and I spend a lot of time there. So if you're looking to get some help and support with adding database driver support or otherwise, I'm happy to open that channel. And Mark has a clarification. We'll make this our last question. Mark says, we've added the database and the charts were fine. In the configuration file, we're looking at modifying them, but we would need to say if DB equals Teradata. So yeah, Mark, I think you have Villa's email, so we can always follow up. I think this still probably needs a little bit more discussion and clarification. And yeah, thanks everyone for coming, and enjoy the rest of your day.
Thanks. Bye-bye.